In the next two examples, we're going to find other values within the formula. So example 2, you have a loaded cart of books with a mass of 25.5 kilograms that's rolling across the floor. If the kinetic energy of the cart is 2550, what is the velocity of the cart? So if we look here, we'll know the kinetic energy, we know the mass, but we have to find the velocity. So we fill in those values. And fix that one. So multiply by half here on this side. And then we're going to divide that into 2550, which I should have there. So this is 12.75. We divide both sides by 12.75. We have b squared. B squared is 200. And don't forget to take square root, and should come back with 14.1 meters per second. And in case you're wondering, guys, because I switched that number, this is the right answer there. Okay, example 3. The kinetic energy of a speeding bullet is estimated to be 2,640 joules. If the mass of the bullet is 32.5 grams, what is the speed of the bullet? Your first step here, don't go madly in and filling in numbers. Remember that mass has to be in kilograms, so you have to convert grams to kilograms, which means you divide by 1,000. So take your 32.5 and move it back 3 decimal places, because grams must go to kilograms. So again, fill in what we know about the formula. And what I've done in this case, I just removed the half first. For some of you, you may want to do that first. You can put your numbers in if you want, but what I decided to do in this case, some of you may want to change the formula around and solve for the variable. So we decided to do that and find the bullet speed. We would remove the half by multiplying both sides by 2. And that will cancel our half here. So we have 2 times kinetic energy equals mass times velocity. Then we have to remove the mass, so divide both sides by the mass, which is what we have here, leaving it with v squared. Now let's put our numbers in. We know our kinetic energy, we know our mass. Remember, that had to get converted to kilograms, so divide by 1,000. So we have here 162,461 decimal 538, and take the square root, and the velocity of the bullet is 403 meters per second. Okay, in this example, a truck has a certain mass and is moving at 5 meters per second. Its kinetic energy is 4.5 times 10 to the 4 joules, or 45,000 joules. The truck then accelerates to 15 meters per second. At the same time, the truck's load falls from the bed and its mass is reduced by half. So as the truck sped up, it dropped its mass off the back. What we're looking for now is what is the kinetic energy of the truck after. Let's find the mass of the truck first. So before it accelerated, it had a kinetic energy of 45,000 joules. We didn't know its mass, but we knew its velocity. Multiply both sides by 2 to get rid of the half here. And you end up with 90,000 equals m times 25, because the 5 got squared. Solve for the mass, and you have mass of 3,600 kilograms. Now let's apply our changes. So after it accelerated, formula here should be 1/2. There. So half mv squared. So half 3600 times the velocity squared would leave you with 1800 times 15 squared. Or you have a new kinetic energy of 202,500. Or 2.0 times 10 to the 5. So even though the mass dropped by half, its kinetic energy still increased. But how much did the kinetic energy increase? So if we look here, and this is what you should pull from this question now. The velocity was made 3 times faster, went from 15 meters per second to 5. Its mass dropped by half. It had an initial kinetic energy of 45,000, a final kinetic energy of over 200,000. If we do a comparison here, you would find that it's 4.5 times greater. So velocity has a much greater impact on kinetic energy than mass does.